Hi, and welcome to the final video for Module 4. I thought I'd start by reviewing what we've done so far. You'll remember that we started with a discussion about the importance of checking. We had some outputs from the INAHOR model. We symbolized those in QGIS. We used some satellite information to check. We did the OpenLayers plugin looking at Google satellites in QGIS to give a very rough check of the accuracy of what we had in INAHOR. And then we talked about the method for generating random points in QGIS and how that was indeed used by the people in the surveys in 2015 for Nueva Ecija. So the last section here on the field survey on rice area. This is a very important distinction that I want to make right now. Everything we've talked about so far has been about checking the rice area, the rice extent, the amount of land that was planted with rice. That's what INAHOR is looking at, and that's what the enumerators in the field were checking in the field survey we just saw, and that we will be using in Module 5. A very important point, however, and a different kind of survey, is a survey that has to do with looking at the actual rice yield. So for a given amount of land, or for a given rice plot, how much rice actually was produced? That's not a question that's directly addressed by the PALSAR 2 images or in the previous survey. There are other surveys that were carried out in this case called crop cutting surveys and also farmer recall surveys. And it is about those surveys that I would like to speak for a few minutes right now. And first, I'd like to talk about crop cutting. That's a yield estimation method that is done by harvesting a portion of a randomly selected plot and dividing the weight of the processed harvested crop by the area of the subplot. We'll talk a little bit about this in the next slide, but important points here are randomly selected plot. You just can't go out and go wherever you want. This has to be methodically done. Dividing the weight of the processed harvested crop, so there has to be some processing here. You just can't take the rice and measure it right there in the field. There needs to be things done to it. And then you need to know the area of the subplot that was the rice was taken from, which is fairly straightforward. The advantages of the crop cutting method are, importantly, if it's objectively designed, we're just going to assume that's done, that first it's unbiased. Now this requires, of course, the identification of randomly selected plots within the sample mesh, so that's important. It's reliable in the sense that you actually have a physical measure of the amount of rice that is in a given area. Estimates within an acceptable confidence interval, so statistically it has some meat to it. And then measurement errors are minimized. This is also related to that point. The disadvantages, as you might guess, are that a large budget is needed and that it can take a long time to collect the data, to clean it, and to analyze it. So that's, of course, one of the reasons why we're going about using satellites in the first place. If this crop cutting or the next one I'm going to talk about, farmer recall, were really easy to do and simple to do, that's all that would need to be done. So these are some important disadvantages we must keep in mind. Now the crop cutting method, first take a selection of 120 different meshes and then a random selection of plots in those 200 meter by 200 meter meshes. Next, there's a tracking of the plot boundaries, this is GPS, and then a random selection of a subplot. So you see the person holding I guess we call that a measuring device. Then the next one is actually the harvesting, cutting of the rice, threshing of the rice, cleaning of the samples, moisture reading and weighing of samples, and then importantly the drying process, which then leads to the final weighing and moisture reading of the dried samples. So there will be notes on how to go about this, and you can go through the information that was indeed gleaned from the crop cutting surveys that were done in Nueva Ecija in the Philippines. But this is basically what the crop cutting method is. Let's look at the farmer recall next. Farmer recall is different. It asks the respondents, the farmers themselves, to remember or to recall information from the past. So farmers may be asked to recall information about production and yield from the previous cropping seasons. They can also get other data in these sorts of surveys and compare that with other data collection methods such as the crop cutting survey. So for example, a farmer recall survey, farmers may be asked information about the household demographics and economics, about the methods that they used to grow their rice, about the inputs and the sales of those products, about the labor they use, and about agricultural extension. Now the advantage is, this is great because it's capable of collecting data from a large number of respondents, and it has a broad range of data that can be collected. And you could provide better estimates if it's objectively designed and implemented. That goes without saying, but I've said it. The disadvantages, as again you might imagine, is it's expensive. It takes a long time to collect the data and clean and analyze. These 2 points are the same as the crop cutting, but there's one extra issue that comes up with farmer recall survey, and that is that measurement errors may still arise because these are, humans answering questions, and of course the recall is not perfect. So those are issues that naturally come up, but this farmer recall survey in conjunction with other methods, such as crop cutting, such as the satellite-based methods, are definitely things that should be in your toolkit.